Hi, my name is Luke Choquette, and this is my AP Statistics final project. Today we will be looking at team three-point attempts versus win rate in the NBA. My question is, do NBA teams that shoot more threes win more games? I chose this topic because the three-point shot has completely taken over basketball, especially in the NBA, and now teams shoot more threes now than ever before, and analysts can constantly argue about whether it leads to more wins or whether it's just a wasted, lazy shot, and I wanted to test this with real data. My null hypothesis is that there is no linear association between three-point attempts per game and winning percentage, meaning the slope, beta, equals 0. My alternative hypothesis is that there is a linear association. The slope is not 0. This is a two-sided test because I'm not assuming the association is positive or negative going in. I will analyze this using a linear regression t-test for slope, and I'll also build a 95% confidence interval for slope. Data collection. I got all my data from landofbasketball.com, and my x variable is the three-point attempts per game for each NBA team, and my response variable, which is on the y-axis, is the win percentage, calculated as wins divided by 82 games, which is expressed as a percentage. This is where I found all my data for this project in the landofbasketball.com database, which is a trusted NBA database. In the fourth column over, there's the three-point attempts for each team, and then each team played 82 games in the 24-25 regular season, so I just divided the three-pointers attempted total in the regular season. I divided that by 82 games, and I got my final number of three-pointers attempted per game. This is where I found the win rate statistic, same website, landofbasketball.com, and then this one gives you the percentage, which is the wins divided by 82. Here's the Western Conference statistics and the Eastern Conference statistics. It's the third column over. Now, this is something to note. This is a census, not a sample. As I have all 30 teams' data, which is the entire population for the 2024-25 season, which means no team is missing. This means we already know the true parameters for this season and don't need an inference to describe it. However, I'm treating the season as representative of how the NBA operates over time, especially in recent years, so my inference applies to the broader long-run relationship between three-point volume and winning, and I'll also revisit this as a limitation in my conclusion. Here's the scatter plot of all 30 teams. Each dot is one team. The orange line is the least squares regression line. One thing to note is the team all the way on the right. That is the Boston Celtics with the most three-pointers attempted per game with 48.2. The 1.5 times IQR test finds that this Boston team is the only outlier. Here are the summary statistics. The correlation coefficient is R equals 0.13801, which is a very weak positive linear association. R squared is 0.0169, which is the three-point attempts per game, explains about 1.7% of the actual variability in this win percentage. That means that 98.3 of what determines winning has nothing to do with how much you shoot, how many threes you shoot. Then we move on to slope, which is beta equals 0.6450. For each additional three-point attempt per game, for each one additional three-point attempt per game, a team's win percentage increases by about 0.645 percentage points on average. Then we move on to the y-intercept, which is 25.76. This has no practical meaning since no NBA team attempts anywhere close to 0 threes per game. And then finally the standard error of 0.9293. Once again, here's the linear regression line equation. The overall form is linear and the direction is positive. The strength is pretty weak and there was one notable outlier. Alright, this is how I completed the 4-step significance test. We have the choose step where I state the hypotheses, which I mentioned earlier in my presentation. Do the check step. For the linear regression t-test, I needed to verify 4 conditions. Linear, the scatter plot showed a approximately linear pattern with no obvious curve. The independent condition, which each team's season performance is reasonably independent of the others. There's a minor concern since the NBA teams do play each other, but this is standard for NBA team level analysis. Normal, the residuals should be approximately normal, With n equals 30, there's no extreme skew in the residuals, so this satisfies this condition. And then finally, is it uniform? The scatter around the regression line looks roughly consistent across all x values with no clear fanning pattern or U-shape. And then finally, random, which wouldn't apply to this, especially since it's a census, so we have all our data. These are my calculations. We can see that the test statistic is calculated as slope divided by the standard error of the slope, which is 0.6450 divided by 0.9293, and then that got us to the t-statistic of 0.69411. With degrees of freedom equal to n minus 2, we got n, which is 30, minus 2 to be equal to 28, and then we got our two-sided p-value, which was 0.4934. Since the p-value of 0.4934 is much greater than alpha, which is 0.05, we fail to reject the null hypothesis. This means there is not statistically significant evidence of a linear association between three-point attempts per game and win percentage in the NBA, when treating this season as a representative of a larger population. This means, put simply, shooting more threes does not significantly predict winning more games. Then I also made a 95% confidence interval for slope. Step 1, same conditions as the previous test. And then this is the formula. It's beta plus or minus t-stat times the standard error of slope, where t-stat for 95% confidence with a 28 degrees of freedom is equal to 2.048. So the interval is 0.6450 plus or minus 1.9031, which gives us our confidence interval with a lower bound of negative 1.2581 and an upper bound of 2.5481. Because our 95% confidence interval includes 0, we can also conclude that there is no relationship between the amount of threes attempted and win rate. This means we are both 95% confident that the true slope of the linear relationship between three-point attempts per game and win percentage is negative 1.26 and 2.55. And also, because this confidence interval contains 0, we cannot conclude that the slope is different from 0. This is consistent with our significance test. So we found both times that we failed to reject the null hypothesis because the p-value is greater than our alpha value 0.05 and the confidence interval includes 0. We find the same conclusion that there is no statistically significant linear association between three-point attempts per game and win rate. So here's a final look at our summary statistics. And here is our scatter plot one more time. Here are the two possible errors we could have made. A type 1 error means that we concluded there is a significant association when there really isn't one. And then a type 2 error would mean missing a real association that exists, which is a false negative. This is more plausible given our case, because we did reject the null hypothesis. And finally, our limitations. Like we said before, this is a census, so this means we have all 30 teams, which is the 2024-25 season's parameters are fully known. Inference only makes sense if we generalize beyond the season, which requires assuming the 2024-25 season is representative of the NBA broadly. And then second is lurking variables, meaning like the player talent, coaching, pace of play, how good your defense is, and injuries all affect winning, probably more so than three-point volume, and correlation is not causation. Third, this is data for only one season. A single season with 30 data points gives us limited power to detect a relationship, a broad relationship throughout multiple NBA seasons, even if one exists. And then fourth, attempts versus efficiency, meaning I measured how many threes teams attempted, not how efficiently they made them. Three-point percentage or points per three-point attempt might be a stronger indicator of, might have a stronger linear relationship to win rate. Okay, this is how I'd improve the study. I would use 5 to 10 seasons of data for much more variation. And then I'd look at the 3-point percentage or net rating instead of raw attempts. And I'd also build a multiple. I'd look at more statistics that include factors like defense, pace of play, and the team budget, how much they're spending on players. The bottom line being, in the NBA, it's not about how many threes you shoot. It's most likely about everything else. Thank you for your attention.